In this video, key concepts about intraday trading, algorithms and intervals are introduced. Here concepts relating to intraday trading are introduced. In charts, the abscissa represents the time, while the ordinate usually represents the price or other units of measure depending on the nature of the exchanged items. So in general we deal with time and price value. Referring to this picture outlining a white candle, we will focus on the terms delineated in the figure and we will refer to them both relating to time and to price value. One of the most powerful features of Trading Conceiver is the possibility to trade not only at close but also intraday, that is within the day, or more precisely within each and every single period, bar, candle, of the historical data. We divide a period into three parts: open, threshold, close. Regarding the time, the open and close are instants in time. They happen at the open and at the close of the trading session, respectively. The price value they occur at is well defined, namely the open and the closing price, respectively. Regarding the time, we will define the threshold as the period between open and close excluded. This is not an instant in time, but a period whose length depends on the historical data because it is a bar or candle long. The price value of this period in time is not univocally defined because it encompasses all the values between the low and the high of the price. The name comes from the fact that usually we have to deal with thresholds, that is, specific values in the threshold phase. It highlights the fact that we are focusing on price levels, that is, values on the y-axis, not on time, the x-axis. The algorithm will be true or false according to the comparison between a threshold and the interval low-high. But the term intraday will commonly refer to the fact that we are not confined at the close instant in time, but are considering the open and threshold too. The term would be apter when referred to historical data when one period, bar, candle is 1 day long. For the sake of simplicity, however, we will use it regardless of the length in time of each period. Here, concepts relating to algorithms are introduced. Trading systems are built using trading algorithms. In Trading Conceiver by trading algorithm, we commonly refer to the output or result of internal calculations. Only the outputs are relevant for the user. The calculations are performed internally and transparent to the user. The two kinds of algorithms the user has to deal with are elementary algorithms, combining of the tabs. This is just a conceptual difference, but they are represented and treated the same way, whatever they represent. The building blocks of a trading system built with Trading Conceiver are elementary trading algorithms. These are already implemented. They are also simple, hence the name. We give enough information to the user to understand unequivocally what these algorithms do. Usually the name of the algorithm is enough. That's why sometimes they are pretty long. Anyway, we always document the formula the algorithm is based on or the Boolean logic of the algorithm, although it is not necessary to know that. A theoretical example might be close greater than simple moving average, where we check whether the close price is greater than the simple moving average. To build a trading system, elementary algorithms are combined together. The combination occurs for each of the 6 steps of the composer. You will end up with 6 algorithms, the combinations of each tab. The combination is performed through logical operators like OR and AND, and the combination is still an algorithm. The output of all algorithms takes the form of true-false values. Each algorithm of whatever type can only be true or false. Internal logic always reports only if the algorithm is satisfied or not. The algorithm consists of checking if some condition is true or false, and the result is output. For instance, in the algorithm close greater than the simple moving average, we would check whether it is true or false that the close price is greater than the SMA. In the table, trading algorithms are rendered as a checkbox, selected if the algorithm is true, deselected if the trading algorithm is false. A typical alternative representation of true and false is with 0 and 1. True corresponds to 1, false corresponds to 0. This is the representation used in charts. On a case-by-case basis, other information might be available. For instance, for stop-loss algorithms, also the stop-loss level is reported. This is just for convenience of the user, who doesn't need to know that. In general, Intraday Conceiver operates not only at close, but also at open and threshold. So the output of the algorithms will be for the open, threshold and close of each entry in the historical file. This means there will be 3 columns for each algorithm. Some algorithms, by their nature or because of some choices by the user, operate only at close. In that case, only the close value is reported and the open and threshold are omitted. This means there will be just 1 column for each algorithm. Here, concepts relating to intervals are introduced. As explained in the previous chapters, the output of an algorithm consists of true-false values. These values are specified for each open, threshold and close. At open and close, the price is well defined, the open and close price, respectively. There is only one value of the price to consider. When checked at open and close, all algorithms give a simple true-false output, a Boolean value. Let's consider, for instance, the hypothetical algorithm price greater than simple moving average that checks whether the price is greater than the SMA. At close, we will compare the close price with the SMA and output true or false according to the result. True where close is greater than the SMA, false where close is less than the SMA. The same for open. We will compare the open price with the SMA and output true or false according to the result. True where open is greater than the SMA, false where the open is less than the SMA. The threshold phase, that is the phase between open and close excluded, encompasses all the price values between the low and the high of the price. It is not a single value like open and close, but a whole range or interval. When checking whether an algorithm is true or false, we need to check all the values in the interval low-high. The result of the check might be different for different values of the interval. In general, there might be some values in interval low-high where the algorithm is satisfied and others where it is not. Of course, the algorithm can also be always true or always false in all the interval low-high. In the same example above, the SMA represents the threshold value to use to be compared with price. There are bars always above the SMA curve, so the algorithm is always true throughout the threshold phase. Other bars are always below the SMA curve, so the algorithm is always false throughout the threshold phase. In still other cases, part of the bar is above the SMA and part is below. For these days, the algorithm is true for the upper part of the bar and false for the lower part. The bar is divided into 2 intervals, one where the algorithm is true and the other where the algorithm is false. Formally, an interval is a consecutive range of values between a left endpoint A and a right endpoint B. In Intraday Conceiver, an interval is always considered closed. That is, it includes all its limit points A and B. It is denoted with square brackets. It can also be degenerate when the left and right endpoints coincide. The union of intervals is the set of all elements of the intervals. It is denoted by this symbol. You can see some examples in the manual. In particular, when we perform the union operation between two disjoint intervals, we end up with two intervals. So the union of intervals can give rise to multiple intervals. In 3D Conceiver, this is noteworthy, as it can happen when combining elementary algorithms together within the same tab. The intersection of intervals is the set containing all elements belonging to all the intervals. It is denoted by this symbol. You can see a couple of examples in the manual. In particular, the intersection can be an empty set, denoted with this symbol. The complement of an interval I contains all the elements not in I, and you can see an example in the manual. In 3D Conceiver, things are simpler. First of all, in 3D Conceiver, an interval is always considered closed. We don't distinguish between open and closed interval. Moreover, we consider the interval low-high as the universe, that is the entire range of possible values. This implies that each period of the historical file has its own universe. For example, let's suppose we have the following values: low, A, B, high. Here is a list of intervals with the corresponding complement. The complement of low A is A high. The complement of A high is low A. The complement of AB is low A union B high. The complement of low high is the empty set. The complement of the empty set is the universe low-high. The threshold, an algorithm, can be false in all the interval low-high, true in all the interval low-high, true in a subinterval of low-high. Examples: low A, A high, AB. True in more than one subinterval of low-high, like low A union B high. The algorithm is false in the complement of the intervals where it is true. For instance, if it is true in low A, it is false in A high. As said in previous chapters, the output of an algorithm is characterized by a Boolean value, true or false. The precise indication in the case of threshold is given by the interval where it is true, as explained above. However, a Boolean value is also assigned to the algorithm at threshold, which summarizes the more complete but also more complex interval framework. The Boolean value of the algorithm in threshold is set according to the intervals where the algorithm is true. False. The Boolean value is set to false if and only if the algorithm is never true throughout low-high. True in all the other cases. So if the interval where the algorithm is true is other than the empty set, the Boolean value is set to true. In particular, the Boolean value is considered true even if the algorithm is true only in a subinterval of low-high. It is not necessary for it to be valid in all the range of low-high. Therefore, the Boolean value says if there is at least one value of the interval where the algorithm is true. The interval says where it is so. In table data, both the Boolean value of an algorithm and the interval where it is true are reported. If the interval is missing, it means it is the empty set. Consequently, the Boolean value is false. If, on the contrary, the interval is present, the Boolean value is true. A typical case where an elementary algorithm is true at threshold is the following. Let's take the previous algorithm once again, price greater than simple moving average. We have the SMA value, that is a reference threshold value, and compare it with the price. In the picture representing a candlestick, the price is greater than the threshold in the green part and less than the threshold in the red part. The algorithm is true in the green interval threshold high and false in the red interval low threshold. The green and red parts are complement intervals of each other. The boundary between the two is a threshold, that is a specific level, which is where the name threshold comes from.